You're gonna have when this. You're gonna have to kind of.
All right. All right, guys. So yesterday we learned about that Great Barrier Reef and how that's being affected by ocean acidification. So did you know that ocean water is actually naturally slightly basic? So it has a pH of 8. So the ocean's not neutral. It's not like the water we'd get out of a tap, say. So the water we drink, this is kind of a review from chemistry. So the water we drink is actually neutral. So it's got a pH of 7. So we consider tap water is generally about 6.5 to 7.5 in pH. So if you had totally pure water with nothing else in it, it'd be a 7. It'd be neutral. Things that are greater than 7 are considered basic, and things that are less than 7 are considered acidic. So the ocean's a pH of about 8, so it's basic. But oceanographers have noticed that since the Industrial Revolution, the pH of the world's oceans has decreased from 8.18 to 8.08. So it's decreased or become more acidic by 0.1. That doesn't seem like very much, does it? It's only 0.1. Doesn't seem like that would matter. But that's actually a 25% increase in the amount of H+, or as acid ions. So a 25% increase in the amount of acid ions in the water. So that's huge. 25% is a lot. 25%, like if you think about your tests, how big of a deal would 25% on your test be? So 25% is a big deal. So we read yesterday that this is greatly affecting the oceans, plants, and animals that live in it. So everything that lives in the ocean, it's a really, really sensitive environment. If you think about like your own body, you have to maintain a pretty constant pH, right? Yep. So your stomach is a lot more acidic than everything else in your body. But what happens if you get an ulcer? It burns, it hurts a lot. If you don't get it checked out, or like your stomach would actually rupture, you'd be dead pretty shortly, just because you exist in a really narrow pH range. So it's the same thing for all these animals. Their lives really depend on the ocean staying how it's kind of always been. So the first thing we're going to look at is how the ocean's becoming more acidic. So we'll go back here. So everybody wants to put their eyes on me. So part 1 of our labs, we're looking at how the ocean is becoming acidic. So how an increase in carbon dioxide in the atmosphere would make the ocean water more acidic. So the big things you'll need for this, first you'll need to get a beaker. What's the first thing we want to do with this beaker?
Don't break it.
Well, don't break it would be a good start.
4 milliliters of
yeah?
ocean water.
First thing though, do we really trust the period before us to have done a good job cleaning this beaker?
No.
Yeah, I don't trust them. So we're going to rinse that beaker out, switch the water around, clean it out. Next thing we have these bottles that have our simulated ocean water in it. So it's salt water with a pH of 8. So this, for our purposes, is the same as ocean water. Next thing I want you to do is go to your materials list, cross out graduated cylinder. We're not going to use graduated cylinders. We're getting upgraded. We get upgraded to these guys. These are called pipettes. It's written out on the board if you want to know how to spell that. These are what you use in a lot of like your college labs and stuff. They're a lot more precise. They're a lot easier to use actually. So how you use one of these. Other thing you're going to change 4 milliliters of ocean water to 10. So in your procedure, go ahead and change that right now. And for this lab, we were nice enough to put a piece of tape at 10 milliliters. So you want to fill it up to the tape. To do that, you want to use this little wheel. You just kind of crank it. And as you spin it, it pulls water in. You can see I'm above, so I'm going to spin it the opposite way till it's right even with that tape. Then I can take it out of my milk jug, hold it over my beaker, and press this. And all my water pours in. So that's real quick and easy. A lot more fun than using a graduated cylinder. Next thing I want to do is I want to add some phenolphthalein. So what phenolphthalein is a pH indicator. So we know that this water is basic or acidic right now?
Basic.
Yeah, it's basic. So it's like the ocean. It's got a pH of about 8 right now. So when I add that phenolphthalein, it turns that pink color. So we know that that pink color is representative of a solution that is basic, right? The phenolphthalein itself doesn't make the solution basic or acidic. It just shows which it is. So this phenolphthalein is going to change colors when the solution is, if the solution changes from basic to acidic, right? So it'll change colors when if that happens. So if it becomes acidic, it's going to change color, right? Next thing you do, you want to take a straw and blow over the top. So you like your wind. Basically just blow over the top of the water. Be really, really careful. You don't want to splash this on somebody. The biggest thing you don't want to do is go to take a breath in and inhale it. Phenolphthalein is poisonous, so you don't want to inhale this. All right. So be really, really careful with that. The rest of the lab you'll figure out as you'll do as you go. So I'm not going to show you the rest. You'll have to just read your procedure for that. Another big thing I didn't do that everybody's going to want to do for labs. How much fun would it be to go to blind?
Fun? Really fun, actually.
Not fun at all. So we always want to wear safety glasses. It's a requirement when you're in labs. Guys, from the time you hear goggles on to the time you hear goggles off, or that you can take your goggles off, you have to have them on. If you don't have them on, you get one warning. After that, you get escorted to the office and you don't get points for your lab, and you get to hang out there. So for part 2 of the lab, we're going to look at how a more acidic ocean would affect the marine environment. So guys,
Are we even going to have time to do this?
yep. So we're going to look at how more acidity in the water will affect the environment. So the ocean has 3 types of rocks, right? It has basalt that forms from the magma ridges. It has sand that comes from those lithogenous sediments that wash in. And it has limestone that forms from the shells and all that stuff from dead animals. So we have those 3 different types. The black, and if you have questions, it's written on the board up front. Black is basalt, red is sandstone, and gray is limestone. So we're going to test how those react to different things. So first, if you turn to your data table, you can see first you're going to write down predictions for what each will do when it's exposed to water and when it's exposed to acid. So why would we test it with water, guys, with just plain water? We talked about experimental design earlier this year. Yeah, so that provides a control. So we can see what change the acid's actually making. So start out with the water. You can just get that right out of the sink. So start out, test all 3 with water. And then you've got 2 beakers that have acid in them. So take an eyedropper full of acid and test each one. There's also magnifying glasses. It's sometimes hard to see these reactions. So feel free to take one of those. So test each with acid, record what you see. Make sure to clean your rocks off between times. But other than that, any questions about that? What we're going to do? All right, guys, go ahead and get your goggles.
Hold up, stop.